Okay. Hello and welcome to our section on numpy. Numpy is really important now. So up to this point in the course, we've kind of learned what Python is, but basic Python, if we were to try to do business analytics in basic Python, it would be a lot of work. We'd have to write a lot of functions. So we saw how to write functions, we saw how to write classes, and if we wanted to do a lot of analysis, we'd need all kinds of statistical functions to do that. Fortunately, most of what we need has been written for us in the form of libraries. So this is kind of why Python is so popular, not so much for the Python basics that we've been studying so far, but really for the libraries that can add in almost almost infinite capability. So if somebody writes a library and makes it open source, you can bring that into your code and use it too. So one of the fundamental libraries, and so think of this as kind of layers. We've learned Python. NumPy gives us a new data type, or really technically it's a class, kind of like we made a hotel class or whatever in one of the earlier videos. This is a class made by NumPy, and it's an array of numbers. So it's simply an array of numbers, which sounds pretty simple. Um, but within that class, they've made a huge number of methods that let you do analysis of those numbers and math with those numbers. So I don't know how much of you've seen this in your statistics class yet. It's not really that important, but I'll just mention that a lot of mathematical optimization can be done well with linear algebra. Linear algebra is where we have matrices and we multiply them by each other. Sometimes an AI training won't work that way. And so a NumPy array comes with methods for adding them, multiplying them, combining them, and doing different analysis. So the NumPy array is like a new data type or a new class, and it comes with a whole bunch of methods. Two things are unique about it. One is all the elements in the array are of a single data type. And that was done so that when you move this data into the memory of your computer, it comes out evenly spaced in the computer's memory. And because it's evenly spaced, math can happen quickly. You can quickly run through all those numbers and do a bunch of multiplications. So NumPy was meant to be fast. So, the Python language itself is not actually that fast. It's slow, but it's a good language because it glues all these things together. When we call a NumPy method, that method may not have been written in Python. It might have been written in C so that it can execute very quickly. So the methods we call from our Python code may be faster than our code itself. Um, let's see. And then one of the last things I'll mention is that a NumPy array is immutable, which was kind of like um, our tuple objects. I was forgetting the word. Our tuple objects in Python. Immutable means if you have an array and you wanted to change one number, you cannot go in and change that one number. But it's pretty easy to make a new array that is the old array with that number change, right? So, you'll have, X equals this NumPy array, Y equals the old NumPy array, with this element changed. So it needs the new to be reassigned. Um, the consequence of that is you'd be actually moving that array around in memory, but you can't just kind of change it and leave it in place. But um, so that's that. So a NumPy array can have any number of dimensions. So we do a lot of stuff in two dimensions, right? Excel's a two-dimensional thing, and a database table is two-dimensional. So we do a lot of two-dimensional stuff in business analytics, but it can have many dimensions. Let's see. Interesting point. How did NVIDIA corner the market on AI training? And here's why. AI training requires two matrices to be multiplied by each other, right? So if matrices are big, then that's a lot of multiplications because it's each element multiplied by each element. And the NVIDIA chip does multiple of those multiplications in parallel, right? So when we do matrix multiplication on a standard CPU, like if you do it on your laptop, even in the collab with the standard CPU, each multiplication happens one at a time. So if you could do 100 multiplications in parallel at the same time, then it would be 100 times faster. And that's what NVIDIA chips do that. And that's kind of why they've taken over. And they've also, their little trick up their sleeve was to anybody that wrote soft Python code using the numpy library could just change numpy to qpy, which is made by NVIDIA, and it would just switch all the calculations to the NVIDIA chip with no changes to the Python code. So that's kind of like how NVIDIA sort of slipped in and grabbed market share like crazy because it didn't take the computer programmers really any work to speed up 100 times. All right, so that's an aside. So what I'm gonna do is I'm gonna give you a quick look at NumPy, and then I'm going to ask you to go to the NumPy website because the NumPy website is going to maintain the latest and greatest knowledge. So you should get familiar with, the websites that own particular libraries that go with Python. We're better off going right to them. We did that a little bit with before, but all right. So, um, you know, uh, Python list. This is a Python list here, right? You know what Python lists are. Um, the second example is a list of lists. And so technically, if you have a list of lists and all the elements of it are the same data type, like this example is integers, then it's more or less what a NumPy array looks like. But you have to make it an actual NumPy array object before you can use NumPy array methods on it. So let's look at that. Here's a little example, right? So we import NumPy as NP. I don't know if I've mentioned it enough. So NumPy is an outside library. It's not part of Python. A different company made it. A different organization made it, and they made it openly available, so it's freely available to use. It's open source. To use that, there's two steps to using open source software in Python. One is to install it, but we skip that step when we're using Colab because Google recognized that everybody wants to use NumPy. So NumPy is already installed. Other computing systems, you might use a program called pip to install it onto that computer system. But anyway, NumPy is installed, but it's not available. The second step is this import. Import makes this library, NumPy, available, and we will reference that library in our code as NP. This is you don't, the as NP is not technically required, but it is the industry standard for using NumPy, so always do it. So we'll import that. I'm not going to really cover IP widgets in this class. IP widgets, if you just kind of another aside, it's really not part of the class. I just did it for this demo. But IP widgets is a way for you to put user interface elements within a Jupyter notebook. So say, right now we've been making Jupyter notebooks with some code, execute the code, and then there's some output. These IP widgets is a way to put some certain user interface within the code to make it kind of like more make a notebook a little bit more like an app. Not really part of the class, but I threw one of them in this example. And so in this example, what I did is I made a bunch of functions that do stuff with the NP array, the numpy array, and I call those functions with my widget, which is a little drop down. So I'll show you that, but not real important to the lesson. The main thing is here, I've got a function create NP array. Again, this doesn't have to be in a function. I just did it because naming that function was a way for me to put it in my widget that I'll show you in a minute. So a Python array is, well, there's no such thing as the word array in Python, right? Technically, all we have is we have a list of lists. So a list of lists is like a two-dimensional array, right? Because you can use your indexing to say the 0th list in the list is this first list, and the 0th element of the 0th list would be this one. So it's a so it is a two-dimensional object, but it's just a list of lists. We convert the list of lists into a real numpy array with NP. Remember, NP comes, this letter NP here, this is valid because of our import numpy as NP. That says when we're doing numpy stuff, we're going to call it NP. So here, NP says, referring to the NP library, call the array function. The argument to the array function is our list of lists, and the output of the function is a numpy array. So the data type, right, the data type of py array here is list of lists. It's a Python list of lists. The data type of AX has been now converted to a numpy array. So first you have to make your data a numpy array, and then use all the wonderful methods within numpy. Okay. And so here's an example. Once you have a numpy array, so X is a numpy array here, you can do X, right? X is now an object of the class numpy array, right? I'm trying to kind of pick my words correctly because we're now object oriented. So that means the class numpy array has a method sum, so we can get the sum by using x dot sum, right? X is the variable name x, but since it's an object, it has methods, and the methods are addressed with a dot. And the sum method needs no arguments because it's going to sum up the numbers in the array, so it doesn't need it. Like functions always need at least one argument, but methods sometimes don't need any arguments because they're already using the information in the variable. So we can get the sum of all the elements in our array with these methods. We can print out our arrays here. We can create an array. So this is a we start out with a Python string of strings. Then we load that string of strings into a numpy array. When we load it into the numpy array, we can set what its data type would be. You can leave the data type off, right? And because these are all integers, it would figure out it was an integer numpy array, but you can also change it. But every single element will, in fact, be the same data type. And that's what's important. Display menu is the IP widgets thing. It's going to display the menu. And this is what the options in the menu do. And so I will run this code. And running this code starts out with a menu here. So this is the IP widget thing I was telling you about. It's not really that important, but what I did is I just made it so I could run those functions one at a time for demo purposes. So create an NP array. I created one. Execute the NP array methods. I created this, right? And so these are and you have to go back up here to look at the order. Should have done a little friendlier user interface, right? Mean, standard deviation, some mean, standard deviation, some mean, standard deviation right here. And data types. Remember, I took the Python list of lists and I loaded it in, changing the data type. See, when it's a string, it has quotes around it. When it's a float, it has a decimal point. When it's integers, it does not have a decimal point. All right. Oh, this is we don't really. I'm gonna even delete this one. I don't need that. It's just showing the data type of a list. We don't need that. And then we'll get here to now. So the tutorials are pretty good, but right. So NumPy is a big, complex class, lots of stuff in it, and we are not going to get to everything in this course. So what I did is there's a single page on the NumPy website here that is really good. It says NumPy, the absolute basics for beginners page, and I'll show you that in a second. And right. And so what I did is as you look at that page, as you look, so there's only one web page that I'm asking you to really look at for this class, but it's a long web page, so I want to direct you. The first thing is, whenever we're using one of these external web pages, I wouldn't really sit back and read it, like a book from beginning to end. um, Read it, and then every once in a while take an example out of it and put it in your Jupyter notebook and execute it, right? That's the way you're going to reinforce your understanding of the material and how it works. With computer code like this, reading about computer code alone doesn't really make it sink in, right? You've got to take some of those examples, put them in your Jupyter notebook, execute the example, make a couple changes to the example, right? Because that's when you really know, you like, oh, well, if I change this, it ought to do this. And that's where you can really teach yourself a lot. So that's why I listed like these kind of things here are almost at the memorization level, because these things, they're all on this one page, but these items on that page are like just the basics of what a NumPy array is and how it works. So these really should be at the level of like memorization. But then as you get into more advanced things, right? We're learning lots of topics. Some of the more advanced topics like these, you need to be aware that NumPy can do those things, so you'll know if NumPy is the right tool for the job. But when you get to doing those things, you may have to look them up. You may not remember, so the basics, memorize. These moderately advanced items, you don't memorize, but be aware of. And then other stuff in the that you can learn on the NumPy page is kind of optional. There's a lot to it. We can't do everything in this class because we've got some other exciting topics to move on to. So do that. Let me just click on this link, right? And it brings you to this page, NumPy, the absolute basics for beginners. It says absolute basics. It's got some like mid-level stuff in it, so it's not really absolute basics. And go through this, and it's good. It has good graphics, and you can copy examples, execute them in your Jupyter notebook, and make some changes to them so you know how they're working. So, and it's just one page to scroll down. You'll see there's a lot of other pages here, and I'll leave those as beyond the scope of this class, but if you want to poke around in that, have at it. All right, so that's basically NumPy is a multi-dimensional array of objects that all have the same data type. The same data type means you can execute math quickly, and there's a whole range of linear algebra type math that can be done, which can be used to train an AI model. Thanks. Have a look.